What is the Space Shuttle's thermal protection system? Imagine flying through space and then plunging back into Earth's atmosphere at over 25,000 miles per hour. The heat generated during re-entry is intense enough to melt metal. How did the Space Shuttle survive these fiery conditions? That's where the Thermal Protection System, or TPS, comes into play. It was a specially designed shield that kept the orbiter and crew safe from extreme temperatures. The TPS was not just one material but a combination of different layers, each chosen for its specific heat resistance. Its main goal was to block, absorb, or reflected heat away from the shuttle's aluminum structure, which couldn't withstand re-entry heat on its own. The most heat-resistant part was reinforced carbon-carbon, or RCC. This material covered the nose cone and the leading edges of the wings, which faced the highest temperatures. During re-entry, these areas could reach over 2,300 degrees Fahrenheit. RCC is a composite of carbon fibers and a carbon matrix, making it both very strong and able to handle extreme heat without melting. Most of the shuttle's underside was covered with high-temperature reusable surface insulation tiles. These tiles were made from silica fibers that could withstand temperatures up to about 2,300 degrees Fahrenheit. They were very light because about 90% of each tile was empty space, which helped keep the shuttle's weight down. The tiles were coated with a black, glass-like material to radiate heat away and waterproof them. Their thickness varied from about 1 to 5 inches, depending on how much heat protection was needed in each spot. Behind the RCC-covered sections, the tiles protected the shuttle's more sensitive parts. Other parts of the shuttle used different materials. Flexible insulation blankets, made from heat-resistant fabrics, covered areas where temperatures were lower. There were also low-temperature reusable surface insulation tiles and tougher tiles called tufies, which combined strength with heat resistance. The upper surfaces had white Nomex felt blankets, which stayed cooler during re-entry. The gaps between tiles were filled with felt strips that allowed for expansion and contraction as the shuttle heated up and cooled down. This prevented the tiles from cracking or breaking under stress. During each mission, astronauts trained to inspect the tiles before and after flight because even small damage could threaten safety. During re-entry, the TPS silently did its job, protecting the crew from temperatures hot enough to melt steel. Thanks to years of careful engineering and testing, the TPS was reliable and made the Space Shuttle reusable. Unlike earlier spacecraft that burned up during re-entry, the shuttle's tiles and blankets could be repaired or replaced, allowing the same orbiter to fly many missions. This reusability meant astronauts could spend more time training and exploring space. In short, the thermal protection system was a complex, layered shield made from advanced materials that kept the shuttle safe from the extreme heat of re-entry. It was a vital part of space missions, ensuring crew safety and making the shuttle a reusable spacecraft. Understanding how it worked helps us appreciate the incredible engineering behind space exploration.